All right, thank you everyone for joining, and apologies for the slight delay. So this is our new webinar in a different time zone because we try to cater to more people and also address different audiences, which is only able really to by addressing people in different time zones. So thank you very much for joining, and apologies for the slight delay for us to start. Our webinar today is about part of the Easier Wednesday webinar series, and we talk about how to plan research grants that further your career. And so in general, eLife's mission is about helping scientists accelerate discovery by operating a platform for research communication that encourages and recognizes the most responsible behavior in science. So in today, we're going to talk about research grants, especially from an early career perspective, from different countries in the Eastern time zone. And so the webinar normally held by the eLife Early Career Advisory Group. And so the eLife Early Career Advisory Group is a fairly diverse group from different continents and from different time zones. And because we have stronger representation in the Eastern time zone, and we would like to also service our community here, we're starting now these new webinars in the different time zones. So thanks for joining, and also thanks for all the panelists. So let me briefly introduce all the panelists who could make it. I think we had one dropout, but this is fine. So who we had today was from the left is Anne Fletcher. You can't see her because her webcam did not work today. But hello. Anne is heads the stromal immunology laboratory together with Dr. Constance Noblich. The group focuses on immunology, specialization of human and mouse structural fibroblasts found in lymphoid organs and disease states. Anne is in Australia at Monash University. The next person on the list would be from India, is Dr. Sabyasachi Rakshit. He's an assistant professor in chemical science, and he leads an interdisciplinary research group whose primary interests are to explore and understand science that is happening in the nanometer regime, using different techniques like spectroscopy to look at molecular dynamics and see at molecular dynamics. And he is at the Indian Institute of Education and Research, Mohali. Our third panelist today is Dr. Che Wei Chuo. And Dr. Che is a principal investigator at the Clinical Research Stem Cell Center, State Key Laboratory of Oncogenes and Related Genes, and an adjunct professor at the Department of Virology at Shanghai Chiao Tung University of Medicine, affiliated with the Rainy Hospital. He's also appointed as Professor of Special Appointment, which carries the title Eastern Scholar by Shanghai Institute of Higher Learning. And his main interest is to work on prostate cancer research. Yes. And our last panelist is Jeffrey Ehrlich. He's at NYU, ECNU, Institute of Brain and Cognitive Science at NYU Shanghai, and he tries to understand how chaotic neural activity is driven by internal dynamics and external sensory input, and how does this lead to coherent behavior. Thank you very much for everybody for joining, and also some of the webinar guests for this really short notice to join us. So I'm really excited about this webinar because I think a lot of people will learn about grant writing, but also how grants are written in different countries with different funding agencies. So this is all really exciting. Thank you very much for the panelists for making the time and to join us. So each panelist is going to have like 5 to 10 minutes to talk about the different aspects she or he thinks when he or she writes grants, and what they would recommend other people to think of, especially from an ECR perspective. And after each 5 minutes, we're going to move on to the next panelist. And at the end, everybody can ask questions, and you can ask questions either by putting them in the webinar question section at the panel, or you can also tweet us at eLife community with the hashtag ECR So with no further ado, I would like to pass on to Anne Fletcher from Dr. Anne Fletcher, sorry, from Monash University.
Thank you, thanks. Yeah, it's exciting to speak to you. So I haven't ever done this before. Our lab recently got flooded, which destroyed everything in it, including our lab laptop, which is why I don't have a webcam. So sorry about that. So my first career tip is don't get your lab flooded, because that's not good. But in terms of grant writing, I think I was trying to reflect back on my first grants and how I started, and I think the main, I sort of split my thoughts into 3 kind of time periods. So one period, like almost half of my tips or a third of my tips start years ahead, really. So it's something that the best time to have started thinking about it is like 2 years ago, but the second best time is today. So if you haven't, don't despair. But if you should be thinking about it now for 3 years ahead, even if you haven't thought about that before. So I think a lot of grant systems, and I've worked in, I'm back in Australia now, but I've also worked in the US and in the UK, and a lot of grant systems have, for early career researchers, have sections on, have you shown kind of aptitude for being a scientist, not just the science that you can do, but leadership and your kind of community kind of giving. Like, are you on Twitter? Are you talking about science? And can you prove that you do more than just sit at the bench? They want to see how you're going to be as a scientist contributing to the scientific community in years to come, which, it's debatable how good and useful it is, but it's something in different grant systems, certainly in the UK and also in Australia, I think slightly less in the US perhaps. It's quite a big deal. In fact, it's gotten me several fellowships where I know I haven't scored quite as well in publications. So it's something where you can get easy marks potentially. So to score well on track record, I start thinking in the next 3 years, what grant do I want to be getting and how do I make sure I measure up well then? So look at where you want to be and think about who recently got that grant and what does their CV look like? How would you be competitive for that grant in 3 years? So I did start doing this during my PhD. It's never too early. And it genuinely has got me quite a few fellowships, particularly my first early career fellowship where I had a number of publications that weren't out yet. But I scored really well on leadership potential because I had taken a number of leadership roles on committees. Our national immunology group, the Australasian Society for Immunology, I was a student representative on that committee, this sort of thing where you can look really good without actually lifting a finger. So it was great. Don't tell them I said that. It has really helped me build my track record and stand out from others, but also public communication, seminars, minor prizes and travel grants, all that stuff can be really important depending on the scheme that you're applying for. What does your system want? So I think a key message I'd like to get across is your system, you need to know it, and you need to know what they value and what they don't, and focus on what they value. Maybe you need a nature paper. Maybe you need a mix of papers and leadership, but every system and every grant is different, and it's kind of like a grant calculus. You need to know what you're going for. Second, I'd say in advance, have a bit of a vision for your research and your career. Like, what specialty do you think you're going to want to really get into and be known for? Because you're building your brand as a leader in your own personal little corner of science. And then thirdly, build the relationships that are going to get you that grant. So talk to people who are leaders in the field, build a good relationship with them. Those are the people who are going to be reviewing you for sure. So think about coming across well to them. If they come and speak at your institute, have a chat and ask them questions and that sort of thing. This is all stuff you can do in advance or at any point up until the grant writing process. And then number 4, learn about grant writing and review processing. So the MRC in the UK, for instance, they welcome a certain number of early career researchers to attend their panel assessments and watch it all. And that was so valuable to go to and learn. You can really see how they make the decisions they make and why. You can see the things they're really unimpressed with and what sorts of controls they like. And really, it's like standing over their shoulder and having them teach you about what they like in a grant and what they hate. So I think those are all things that you can do in advance. But then there's a bunch of shorter term stuff that I think you can focus on sort of 6 to 12 months ahead. And that means that's things like reading the assessment criteria for the grant you want and looking at how well you fit. Look at whether or not it's worth you applying. ask around. You know, if you maybe you need another year to work on it, then maybe think about that. Like, don't waste 3 months of your year when you've got this kind of really short period of time to get grants and get funding and promote yourself. Make sure you're in a reasonable position, but by the same token, but don't be too hard on yourself and too scared to apply. A lot of people are so self-conscious about getting themselves out there and taking this step. So there's a sweet spot, you know what I mean? Know your grant system and your funder. I find that super important. So get a hold of those successful grants from other people in your institute. And one thing I learned that I found quite surprising was that every institute I've been to seems to have their particular grant where they have a disproportionate amount of success. At the University of Birmingham, when I was working there, they had a huge success rate for Marie Curie fellowships. It was like 30% success. It was insane. They just knew how to write those. And so they could give you really good examples of successful grants. They just knew the formula about how to get a great score for it. And it also gave you these amazing examples that you could be inspired by, so that you don't have to reinvent the wheel for things like training plans or, you know, the easy marks in a grant, not necessarily your science. Obviously, that's all going to be really individual, but the stuff that they're looking for that is going to be very similar grant to grant. You know, you don't copy it, but you can be inspired by it. You need to adapt it to your situation, but you can kind of keep the bones very similar. And even the presentation, you know, they've got a great way of presenting that kind of information that grabs a reviewer. Then, you know, you can be inspired by that. So find out at your institute what they're good at getting and go for that, and they'll have a good feel for it. So I think that's like a really, you can get some easy marks by doing things like that. And then lastly, like after all that, then start thinking about what data do you need for that compelling grant application. So about 6 months or 12 months out, start thinking about what data you need. So make some dot points about your preliminary data and what story you've got, and just think about how you plug the holes to make a really compelling story. As an early career researcher, you've got to be conscious about how you're going to differentiate yourself from your boss without treading on their toes, and that can be really tricky. So, you know, this is a relationship. Our entire adult lives, our entire working lives are all about relationships at work, and this is a really, really important one. So it's great if you can get on with your boss. It's really helpful. If you're a creative scientist, then it's not too hard to differentiate yourself. It can, but some bosses are grabbier than others, and they'll care more about what you can take and what you can't. So that's something really individual, but it's certainly something to start thinking about early, and start thinking about that. So, but there's always a billion more questions than there are people to answer them. So if your boss is someone who does want to kind of keep everything to themselves, then just think creatively, think about what you're interested in. And then lastly, writing the grant. It's almost like a minor point after all of that, but the first page is the most important. In every grant system I've written in, that first page is crucial, because your reviewers are reading 20 or 30 grants, and if you don't grab them with your story first up, that's done. So it makes it a lot easier to get people to read your grant, because you can actually just give them the first page quite often and say, this is you know, your first grant will have a bit of an overview of the problem and usually jump into your aims. So, and maybe a little schematic. So get feedback on that first. Don't write the whole thing, just get feedback on that first page. And so far that's been the same for me everywhere I've worked. Yeah, start out with those aims, flesh out the rest of your first page, make it a compelling story, have a little bit in there about why you're the best person for it. But if that first page doesn't grab the reader, you've got greatly reduced chances, no matter how good the following pages are, because those first impressions really matter, I think. So yeah, definitely get feedback on that first page before you write the rest, I would say, and then get feedback from others when it comes together, maybe 2 people, not 7 or 10, because they'll all think slightly different things and you'll drive yourself crazy. You'll end up with a patchwork quilt of a grant that kind of, you know, it'll be kind of a beast of a thing. So just try and get a couple of people that you really respect, and keep the stats in mind lastly. So just remember that this is all a game of statistics in a way. Like, even Nobel Prize winners don't get every grant they apply for. So you need to kind of keep the stats in mind. If you know that this particular grant has a 12% chance of success, just remember you're probably going to need to submit several grants before you should realistically feel hard done by. So rejection doesn't mean your science is bad. It just means someone didn't get you or get your story, or you didn't get lucky with a panel who really appreciates your scientific niche. But it's not the end of the world, and we've all been rejected, I'd say. That's me,
cool.
Really.
Thank you very much.
Too much
No,
blur.
it's all good. It was really good. I think it was a very nice few, like broad view about like different topics and really like actually about strategic thinking, which made me think too. So that's great. Thank you very much. And for this, our next panelist to talk about a different perspective from a different country. So we had Anne from Australia, there's Dr. Sabayashi Rashid, sorry if I pronounced the name slightly wrong. And he's from the Indian Institute of Science and Education and Research in Mohali. And we have a couple of slides here, so I'm going to walk through those. Please take it away.
Hi, yeah. So first of all, thank you very much for keeping me in this discussion. I really enjoyed Anne's talk. And so what I'm going to do here is I'm going to give you my perspective when I first time wrote a research grant. This is a little different because when I was proposing my grant, it was way out of my research expertise. I was trained as a material chemist and then learned during my PhD, and then I learned instrumentation on single molecule biology during my postdoc. And I was proposing to work on molecular biology as an independent researcher. So it was difficult for me to convince reviewers. So I did really I planned it in a different way. So first thing I kept in my mind was first you find the question. Yeah, maybe you can go to the next slide. Yeah. So I find the research objective, and then I try to explain or try to address the objectives or the specific aims using my expertise. But of course, when I presented that work to, so the first research grant I wrote was to Wellcome Trust TBT India Alliance, and it was bound to come to me that your expertise doesn't match with your proposal. So how are you going to deal with it? So that's where I thought maybe I will share my experience, how I prepared my project proposal, and finally convinced them that I could do it. So yeah, so when I was preparing my proposal, what I do usually, even I follow that trend now also, whatever is the, so every grant agency has their own schemes, like how you write the proposal and things like that. But what I do usually, the first page of my proposal contains these four points. I first express my hypothesis for the proposal in one sentence, then I go for objectives again. I try to summarize in one or two sentences. So this is a broad objective, and then again briefly, maybe in 2 or 3 sentences, the experiments which I'm going to carry. Now this is important because here I wanted reviewers, wanted reviewers to know that what kind of equipments I'm going to propose to do these experiments, because my background is as a molecular biology and biophysics. Yeah. So then, no, can you please go back, Benjamin? Yeah. Sorry. Yeah. So and then the prospects, which includes like the futuristic view of it, and I follow eLife's the questionnaires which is given in their cover letter. So when you submit a paper in eLife or manuscript in eLife, there's a questionnaire which comes as a cover letter, and I found that very important, and I follow that pattern to write these perspectives. And then of course you want to make your research proposal as simple as that. So graphical presentation is the best way to represent. Now this is true for anybody and for any grant writing. Yeah, maybe can you move. So next thing which I planned is the amount of grant which I'm going to ask, like the amount of money which I'm going to ask for this proposal. And there are a few factors, the 4 factors which I have listed here. Grants for equipment, as I told you that mine is molecular biology and biophysics, so I really depend on instruments, and it's a major thing which I need to look for. So what I do when I list the equipments which I need, like which I did for the first grant, I listed the equipments which I needed, and then I just, so in India, in most of the institutes in India, I'm sure it is true for many other countries also, we have a central instrumentation facility, which is like institute takes care of that facility. So we have all high-end equipments in that facility, and for researchers from the institute can access at free of cost. So that's a very good thing. Like most of the equipments which we use for our research are available at free of cost within an institute. So when I ask for equipments, I just list out what we already have, and we have full access to those equipment, and then what I need. Now here again, when I decide that this equipment I need to buy for our own research, then so first time I made a mistake while applying to Welcome Trust DBT. I only gave them the budgetary code, but that's not true. Actually, I then realized that the actual price and the budgetary code, there is always 2 to 5% inflation. Like you always need to keep a margin in the higher side when you are preparing fund for equipment, and this extra fund is mostly for logistics, and then we often import equipment from Europe or from United States. So always there is a margin in the currency conversion rate as well. So these things we need to keep in mind when we are deciding fund for equipment. And then comes fund for consumables. Now, as a beginner, I had no idea how much I would need because I was not trained as a molecular biologist. So I had no idea how to, how much consumable money I would need to run a molecular biology lab. So I then traveled around the other labs in the same department, in other in the same institute and in other institutes also, and try to find out how much is their annual budget for consumables, and what are the cost most cost effective items which they buy. And then accordingly I listed my chemicals and found like something around maybe in Indian rupee it was 15 lakhs, which I figured out would be sufficient per annum for the consumables. So then this is how I developed the consumable grant. And one more thing is, like, now grant for student or postdoc or manpower, this is something in India we never really care much, because most of our students or postdoc scholars, they come with their own grants. So government actually funds our students generously, and that's where we really don't care or we don't pay much attention when we write grants for students or manpower. And then next comes the travel or professional development, which is always there, some person which you always include in that. Yeah, Benjamin, can you go move to the next? And then of course everybody would like to know how fast or what time you would require to finish these grants. And again, for the beginners, a few things I didn't know and I wanted to mention here is that often when if our research is very much instrument dependent, then one thing which you need to keep in mind is that starting from the order till installation, it takes at least 6 months. So if you're writing a grant for 3 years, then please keep that in mind, because 6 months is gone in that way, and you have to be prepared for it. And usually the consumables also from here, if these consumables the chemicals are really exotic and needs this is something very sensitive, then we always import again from Europe or from States, and that is again takes at least 2 months, starting from ordering to getting those chemicals. So these are few things which I wanted the beginners, when they're preparing for fund writing, to keep in mind, so that will help them to propose the exact timeline. And the output, I already mentioned that the questionnaires which is given in ELI cover letter is really helpful, and if you can address those questions, then that will set your output for the project. Yep. I think I'll go to the next. I may need to skip. Yeah. And then once the grant writing is done, as Anne mentioned, that you have different time scale, preparation time for the amount of grant which you're writing. If it is a really big grant for 5 years, then you spend a lot of time. If it is a short grant, you spend less time. But always what I do is I keep my next proposal ready, and then I wait for grant openings. And the few resources to check grant openings for Indian scientists are listed here. One is the site in NCBS, and then there is another one is in Indian Bioscience. These are really helpful and can give you timely open, like can show you the grants opening pretty on time. So yeah, that's all which I keep in mind. And before I submit my grant, I always go to my peers in the institute and outside and discuss with them thoroughly about my proposals and take their feedback seriously. And that helped for the first time when I was defending my thesis to Wellcome Trust DBT India Alliance reviewers. And many questions they asked me are already, I was asked by my peers, like my colleagues and my friends in the other departments. So that helps a lot. Like the more you talk about your proposal and discuss about it with your known circle, they will come up with interesting questions, or they will point out the mistakes which might have made. So that gives you a second chance before you go to the actual reviewers. Yeah, with that, I think I'm done with my part of presentation. Thank you once again.
Thank you very much, Dr. Sabiyashi Rakshid. It's really nice to have a different perspective from a different system, which we normally don't cover so much, which is India, and how this has like its own peculiarities and different issues, which people need to be aware maybe if they go back or move to India. So thank you very much for providing us with this very insightful perspective. So our next speaker will be Dr. Chai-Wai Chua, and from Shanghai Chiao-Tung University of Medicine, one of the many affiliations. So please, Dr. Chai-Wai Chua, take it away.
Yeah. So can I have my slide on?
Yep,
so basically, I'm going to talk about a more technical aspect of how we should actually prepare for writing a grant. Basically, it's an extension of what Sachi have actually briefly actually talked about at the first slide. So can you go to the next slide? Yeah, so basically, there's a couple of things I think you have to really consider before you're planning to write on a grant. So, ideally, this, grant should be something to be what we call an extension of a previous published work. So if let's say, you have a publication of that work, or you basically you have a lot of prelim result, that probably would be the best. Because with the publication, people actually know that you already have some good result on that. So that actually give you the confidence, or give the reviewer the confidence that you would be able to complete the task or the proposed work. And then if let's say you don't actually have the published work, it's not end of the world, but you can still supplement it with a very strong prelim data. So what I mean strong prelim data, I will actually go into detail later. So this I will talk about it later in later slide. So and then and you also have to think about what would be your hypothesis. And then, and what typically, I'm actually from a biomedical background. So basically, we always talk about three specific aims. So what are your three specific aims, that you would like to actually put down in that grant, and what would be the preliminary result for each specific aim? So specifically, whether that actually support the foundation of the aims, or they can actually be to show that you actually are competent in doing the experiment in the proposed work. And lastly would be the content. So in which this usually start with strategy, and then your experimental design, anticipated result, and also some potential limitation for each aim. So can you go to next slide, please? So I think I actually have a title there. Is the hypothesis. So what is actually the hypothesis? This should be something you can actually test, and then you can answer yes or no. So for example, I give I think probably this might not be relevant to everyone, but I give you, in the example that I have, in one of the grant. So probably, for example, we can actually like hypothesize. For example, we know that okay, we identify this LGR expressing epithelial cell. So first of all, we want to test whether they have a stem cell property, and if let's say they have stem cell property, could they serve as the cell of origin? And then after like they become cancer, could they actually serve as a like what we call cancer stem cell that can actually contribute to like for example drug resistance, etc. So this one should be in one sentence that actually cover all your specific aims. So and then after that, it will actually then break into like the three part, so which is your specific aims. So can I move to the next slide? So for the three specific aims, typically, like what you need to, like how you actually have to structure it is, it has to be related but independent. So meaning that you basically you have to have something which is related, but without like for example, if let's say you feel one like aim, you can't actually have positive result or what. So it won't actually hurt like you to actually work on the second aims. So this is what we call like related but independent. So this is very important because like the review will actually challenge you if let's say you your your specific aims is dependent on each other. So that actually means that like you feel one, so the second one you probably would not be able to answer. So that is actually not a good thing. So like for your preliminary result, so what can actually call a preliminary result is basically like what we there's a two criteria. One is the fundamental observation that support your proposed aim, and secondly like what I told you just now, like the result that actually show you you are capable of performing the experiment that you propose. So for example, like just now, I give you three different aims. So one is about testing their stem cell property. The second, whether they can generate cancer. And the third one is actually what their role, like during the treatment resistance. So you can actually see my the preliminary result that I actually give, like is what is actually the evidence that actually show this cell are actually stem cell. So for example, you can actually show them they can actually generate a progeny, like something like that, like in different assay. And then and also, like you can also show some preliminary result that actually show that you actually have an assay to test on, like a so-called progenital property. So this is what we call the result that actually show you are capable to perform the experiment. So for example, the second one, I'll give you another example again. So you also actually can actually show that, for example, you have actually shown that previously using a different cell population, you have shown that that population, which is a stem cell, will initiate tumor. So now, like, that can actually serve as your foundation to support you to actually test the idea this novel stem cell, whether they can also serve as like a cell of origin. And then after that, your essay as well, the preliminary result. And lastly, like basically, I think I won't go into detail, because this is too specific. Can I move to the next slide? So later on, like we also have to actually talk about the content of each specific aims. So like what actually Sachi actually mentioned just now is it's really good to actually give a diagram, like for each specific aim. So for example, like you can actually give people a flow of what you are going to do on each specific aim. So for example, like the strategy usually is it involves just a sentence that actually describe what you are going to investigate for each aim. And then after that, like you come up with the experimental design, the detailed research plan. So you describe the methodology, and then like what I told you, like it would be helpful to actually have a flow, like a flow chart of your proposed work. And then after that, like you should also have some anticipated result. So what is the expected outcome based on each experiment. And lastly, is the potential limitation. This sometimes, is a killing, point for the grant as well. Because some people actually just say, oh, this model is not good. Then the reviewer might ask, if let's say it's not good, why would you actually even, started, at the beginning? So you should actually phrase your potential limitation very well. You can actually say, okay, this essay might not be sufficient to support your claim, but then, in your experiment design, you can actually have, you have actually proposed to actually have another additional essay. So with 2 essays, so that actually your that will actually support, your claim later. So I think this is something, more technical part of, the grant that I have actually worked on, when I was in, at Columbia, as a postdoc, and also, after I moved to China as a principal investigator. So I think that's all from me. I can actually take question later.
That's a very nice lead into the next thing. So everybody who has questions, please put them in the questions section of the GoToWebinar panel, control panel. So there's a section where you can put your questions. Alternatively, you can also tweet questions with the hashtag ECR Wednesday on Twitter. Let me try to pick some up. Thank you very much, Dr. Chai-Wei Chow from Shanghai Chiao Tung University. That was very nice, different perspective again from a different system. The different systems we don't hear much usually, but it's nice to have these different experiences. Also, there's this detailed introduction of how to write grants and address weaknesses and strengths. So last but not least is Dr. Jeffrey Ehrlich from NYU Shanghai, and please take us away.
Hi, thanks for including me in this webinar. It's also my first. A lot of what I was planning to say has been said by earlier presenters, so that makes my job easier. I can just, I'll just hammer home a few points that I think are particularly important. So the first thing that I wanted to suggest is, which Anne really hammered home, was that you should know your audience. So depending on the grant, the grant may favor bold new ideas or incremental progress. So Dr. Chua kind of gave an example of, I would say, more incremental progress grant, like a classic R01 or like general grant. But there's also some grants which are like innovation grants or really like high risk grants. And so it's really important to know your audience. What's the kind of grant that you're applying for? Some grants are really more fellowship grants, and some where they're analyzing you as a scientist, and some grants are really focused on the research program where they're analyzing your research proposal. So it's also really important, again, to know whether the evaluation is going to be more on you personally or more on the research program, and that can help you focus your efforts. And of course, along this line is who's reading the grant. In addition to the institute that is funding the grant, you really want to know how the grants are evaluated. If it's a government grant, it's usually other scientists, but if it's a private foundation, they may have a different process, and it's very helpful to know who you're writing for. And this is one tip that I try to kind of communicate to all of my students and trainees, and this is not just for grants, but I think in general, that whenever you're writing, you should exercise role-playing. You should put yourself in the mind of the reviewer, of the reader, and try to think about, if I was reviewing grant and I have my own work, my own projects, my own family, all my other commitments, and I've volunteered to participate as a reviewer, like, what's my attitude going to be, and what do I want to read? So you want to make it as easy as possible. Just, again, emphasizing what the other speaker said, your first page is the most important thing. Your specific aims are the most important thing. If that's not clear, the reviewer is going to be already like writing you off on page 1. So the page 1 is definitely the most important thing. Again, like, are people reading the grant going to be in your subfield so that the grant can be extremely technical, or are they going to be more generally in your field, or maybe even just broadly in life sciences or physics or whatever? And that also can change the level of detail and the kind of the specificity of your grant. And again, reinforcing that it's really important to not start writing grants or thinking about grants after you hear about the grant. As a scientist, you should always be thinking about your plans and your vision, and you should have grants ready. And in China, that's, I think, especially important, because sometimes grants are announced with a very short turnaround time. And so it's very good to sort of like have a grant or 2 or 3 in your drawer, so that when a grant is announced, you can be like, okay, this is the grant I'm going to submit. Maybe you tweak it a little bit, but you shouldn't really wait for an announcement to be thinking about writing grants. A few other points. So even if you don't have preliminary data, obviously it's better to have preliminary data, but something that I think is really important, especially in neuroscience, where sometimes we don't have as clear outcomes as molecular biology, that it's really important to use synthetic data in your work in general, but in grants as well. So if I'm reading a grant and I want to evaluate your analysis and reasoning ability, one way to show that is to say, these are the experiments that we're going to do, and these are the kinds of results that we might see, and you can have figures that you've made out of synthetic simulated data, and say how the different outcomes will lead to different conclusions. This is like a very clear visual analysis, and also by using synthetic data, this is true not for grants, but for papers as well, you can always validate your analysis pipelines and make sure that you don't have any logical errors or bugs in your code. Which is a big issue in some fields. Again, I want to emphasize what Dr. Fletcher said about building relationships. If you're a PhD student or a postdoc, every time a seminar speaker visits your institute, you should sign up for lunch or dinner or whatever you have at your institute, because you never know who's going to be on that panel. And I know it's hard for introverts, especially, to kind of make connections in these group settings, but you should make effort to try to overcome those issues. And it's just a fact of science that building relationships is important. And if it's hard for you to do that, it's definitely something that you should try and work on. And some things that are particular in China that I was in the US for a long time, in New York at NYU and at Princeton before coming to China. And a couple of things that kind of caught me by surprise is that anything that you need to budget for a grant that you need to get from the US can be like 3 times more than it would be in the US. So there are some things that are much cheaper in China, and if you can get something that's made in China, it's generally cheaper than the American brand. But if you need a reagent or you need a piece of equipment from the US or Europe, you have to ask someone who's already in China, or get a budget ahead of time, and make sure that you really can pay for the research that you have, that you've planned. And I think a lot has been said already, so I think we can just move on to the question period.
Cool, thank you very much. It was great, and also like an interesting perspective from people moving from the US to China, and also think about your local environment in terms of budgets. So this is, I think, a very important point if you move across country. Thank you very much for raising this point. So we have questions. So right now we don't have anything from the audience just yet. So maybe I would like to have a question first then. So I had a question for the different panelists, and maybe some people can provide a quick answer. It's about, many people talked about preliminary data. So, and it's well aware that, yeah, you put a lot of preliminary data in your grants. How do people feel about, instead of actually only including some of the grants, pre-printing some of your work and maybe having a wider audience and such, and just putting into grants? Or do some grants maybe even not allow for putting unpublished data into grants? How does it work in the different systems?
Hmm.
Who wants to? I guess I would say I'm not aware of any grant agencies that consider preprints to be published work. So anything in a preprint that's not published in a peer-reviewed journal is still considered preliminary data, as far as I'm aware. So I don't think there's any cost to submitting a preprint before you submit your grant.
Yeah, I think so. I mean, I also think in a similar way, at least for me, since I was being a different in the field before and then trying to get funds for molecular biology, I had to show some data, but I think I had a substantial amount and which like, well, technically I didn't upload it in the bioarchive, but I was sort of thinking to upload it and you know, present the same thing that I have already done it. So yeah, if you can find. But I think it should not trouble much. Yeah.
I think it's a fascinating idea. I mean, I'm writing a grant at the moment and I have very limited space to include preliminary data, but I think in our system would be able to reference something in bioarchive, and that would give my reviewers a chance to see more data. Even though it's not peer reviewed, it's kind of like influencing the jury, isn't it? Once they've looked at it, you can't kind of take that back. It's a bit cheeky maybe, but it's an interesting thought. I hadn't really thought about it before.
Yeah, although I would say, like, you don't want to necessarily depend on them not only reading the grant, but also reading the preprint.
That is true.
I was reviewing abstracts for a conference, and some people kind of cited some archive paper or bioarchive and sort of took that for granted. And I was like, I'm only supposed to read a 2-page abstract, not like read your paper. And then
That's true. There's something to be said as well for not annoying your grant viewers. If they think you're trying to scan the system, they might get annoyed with you. But I don't know, it's cool to ask around to see what others think. It's kind of cool.
Thank you for the different opinions of this. So by now we have a couple of questions. So the first question is from Shraddha Shitut. And the question is, when asking other scientists to review your grant before submission, how broad should you go? There's always a risk of them not finding your question as exciting or pushing as you do. So how broad should you go if you try to solicit feedback before you submit?
Well, I can talk to that one because I've just had to think about it. Again, you need to know your grant. So depending on the different system, you'll have a panel that's for some grants and some systems, you'll have a panel that's really intimately into your little niche of the world. And for some different grants and some countries and some systems, it will be a broad panel who cover all of science, and maybe lay people on the panel or that sort of thing. So you really need to have people review it who are a microcosm of your potential reviewers.
Yeah, maybe I'll put a different perspective as well along with Anne. So if you are thinking of going like broader in the objective way, or for the overall like the question which you're trying to ask, then I think it's wise to go as broad as you can. But then remember that to convince a grant agency or like when you consider this as a successful grant for you, you need to publish in between also. So keep small objectives which you can connect to, you know, achieve the big objective which you are proposing. Yeah, so I think that's important.
I also want to actually, you know, like comment on that on this, you know, like this question, because I actually feel that, you know, it's always not the issue, you know, like to actually, you know, let the scientists to understand, you know, your grant, but it's actually you know, how to let you know, like other, like the public audience, you know, like to understand your grant. So usually, you know, like now, you know, especially like certain grant that actually for example, you know, like those grant that actually supported by Prostate Cancer Foundation, for example, you know, they always have like, you know, like the advocates, you know, like and also, you know, like those you know, like the patients, or even like, you know, like the you know, like different people, you know, like that actually work in the industry, so to actually read on the grant. So how would you be able to convince, like, you know, like all those like you know, like people? That is like the more crucial than, you know, like to actually like convince like the scientists that actually your grant is actually is very sensible, So I would actually suggest like like the like always give it to your your maybe your wife or your your family. They're not like scientists, like then ask them whether they can actually understand what you are writing, especially the layman extract, like so that is one way you can actually like improve your grant, like especially in that aspect. Yeah.
Yeah. You should always have an elevator pitch for all of your ideas. So if you're like stuck in an elevator with Bill Gates and you have like 30 seconds of his time, you should be ready to justify why he should give you money in 30 seconds. It's a great exercise.
Cool, thank you.
Cool.
Yeah, again, it's really about knowing your audiences and maybe also modularize your grant and give different sections to different people and with different kind of expertise. I think that might be something which is worthwhile to think about. So we have one more question here. I'm not sure from who, but how do you write a proposal to keep ready in a drawer if you're not sure which scheme and what focus it will have? So like people talked about, okay, you have to be ready to submit grants any moment in time, really, especially maybe like in some countries. But how do you adapt them, or do you adapt them for the different funding schemes, or do you have different grants for different funding schemes?
Well, Jeff,
Yeah.
you want to reply or
Go
shall I?
ahead. I mean,
Yeah. So like often what happens is if like you are not going to change no matter where are you submitting, but you are not going to change the major part of your proposal. For example, experimental details and things like that. So only thing which you would change is the objective. And as Anne and Jeff both mentioned extensively that you see your like who is your grant agency, who is going to read your proposal. You can change that small part and include it, and then you can submit the whole. So essentially what you're doing is once the grant is announced, you start working only on the objective, and like you just tweak it in just to address the specific set of reviewers, and then the rest of the part is all done. So it takes hardly like few days for you to prepare and submit. That's what I guess is needed.
so one thing I would add is that so I only have moderate success so far in getting grants from Chinese government. I had a grant from Shanghai, a few grants from the Shanghai government, but I haven't actually gotten a grant from the Chinese national government. But in China, at least, there are, let's say, what's trends or like political waves, and it definitely is very smart to be aware of those. And again, you don't have to change your whole grant, but in the justification, in the background, and like what the outcomes will be, it's good to align your grant with the current, like whatever the current political view is about what's the important direction for the country for science. And some people may feel like, I don't know, that anxious about playing political game, but everything is a political game. So I think if your life will be easier if you're willing to like understand the system and play the game.
True, yeah, it's same in India as well.
Yeah. So we have one more question. I think this is going to be the last one, so we run out of time for today. And the question is, do you have any research idea? What is the most common reasons for failure of health research grants application, vice versa? Or okay, maybe let's rephrase it more general. Like, why do you think most grants fail?
Lack of funding first.
Or maybe like the question is like, okay, like what is the don'ts of a grant? Like, what should you not do?
Should you not do? Oh, I can give one tip. Don't be arrogant. So a lot of young scientists feel like the way they write is like, everyone before me is an idiot. I'm a genius. This is the way forward. Don't write a grant like that, because the people reading your grant are the people you're insulting. It's always good, even if you think that, you should always write it as, there's been amazing work before me, and my work is extending all of the fantastic foundations that have been laid by the previous generations. So, like, be positive, don't be negative. It's very dangerous to be negative in scientific writing, and whether it's grants or papers. So try to be positive. And also, going back to something else that people said is like, if you have to be super enthusiastic about your own work. If you're not super enthusiastic about it, it's going to be hard for you to convince other people to be enthusiastic about it. So in your writing, that has to come across that this is like the most exciting thing, and you just can't wait to do the research and blah, blah, blah. So that would be my don'ts. So don't be negative and do be enthusiastic.
That is true. And
Yeah.
I reckon sometimes that means that when you're writing the grant, some days it just doesn't happen because you're not in the right headspace to sound really positive. If you don't believe you're the best person to do this and it's the most exciting work ever, sometimes you just can't write it that day and you have to step away and come back to it another day when you're in a better mood.
And then one more thing just to add, like as Jeff also mentioned, like if you are so I think we should not compare models like some existing model and then I claim to give a way different model which is more useful or something of that statement, this kind of statements. Or let's say, for example, you say that no, cell culture is wrong and I'm going to now work on the 3D models because it is more appropriate. These kind of statements I think I would avoid. Because my reviewers may be from the cell culture background or just to give you
Exactly.
so yeah.
Also, oh, sorry.
No, go ahead.
No, I already talked. You go.
So I have actually two things to add. Like one thing is about the literature review. Always, come up with the latest, literature. Like for example, what is actually happening in the field. So don't simply just, cite, different paper just because they actually support your hypothesis or support your work. So you actually have to know the norm, or what actually is the view of the field, at the moment. So you have to actually say that, and then after that, you can actually come up with how your work actually can actually supplement, on the current, and or actually improve, the current understanding, like that is one thing. And also, if let's say you get a chance, because we all have been, before moving to this independent position. So I basically, I actually we when you are a postdoc, you probably have a lot of chance to actually read the grant from your boss. So basically, just read more, and then just keep reading. And then sometimes what I actually found that which is very interesting is that the best grant that we actually think, oh, this grant, is throughout these 5 years, I found that it's the best grant that I have seen my boss actually writing. But that grant actually didn't actually get it. Sometimes, so like just don't feel bad. Like if let's say you don't get a grant, because you have tried your best or what. But you should definitely you should definitely keep trying. If let's say you can't actually have it funded in this funding agent, you can always go to another funding agency. Maybe it will work for another funding agency. Yeah. So
cool, great. So we can allow one more tiny question. So one thing what I would recommend people to avoid is acronyms. Don't use acronyms. Like you're not sure that people who read your grant understand those, so just leave them out. Okay, we have maybe Anne Crab, but I think she left, or I can unmute. Okay. Oh, Anne, are you here? You had the last, no, she left. Okay, so she left. I think we're also right in time. So this brings me to the end. I think thank you very much for everybody for joining us. This was Dr. Anne Fletcher from Monash University in Australia, Dr. Sabasiachi Rakshid from Indian Institute of Science, Education and Research in Mohali, Dr. Chewa Cho from Shanghai Cho Tong University, and last but not least was Dr. Jeffrey Ehrlich from NYU in Shanghai. Thank you very much for taking the time to talk with us and providing so much insight into grant writing. It was a great pleasure having you. The one last thing I would like to mention is that we have the next upcoming seminar. It's going to be on the 25th of May, and it's going to be mental health support for early career researchers. Watch out in the space. We hope to organize one in the Eastern time zone again. Thank you very much, and thanks to all the panelists for making the time and sharing your wisdom. Thank you. Bye.
Thank you. Bye,
Thank
everyone.
you.
Bye-bye.